All right, some more applications here. We're going to talk about linear speed and angular speed today. In general, what we're doing is just unit conversions here. If you've ever taken, a chemistry class, you might call it factor labeling, but ultimately what we're doing is converting from one unit to another. Okay. So one thing that hopefully we know already is that speed, which another word for speed would be rate, is distance over time. Okay, so like we have many that we're already familiar with. So for example, like feet per second, would it be a type of rate? Miles per hour, right? We have a certain distance, whatever unit that is, these are just common ones, over a unit of time, right? So that's how we find speed. So now let's think of this in terms of something that's rotating, right? Or something that's moving over some sort of curve or arc. So in that scenario, we have consider a circle of radius r. If s is the length of the arc traveled in time t, and the speed of the object is this time going to be arc length over time, or s over v. So even though this says arc length over time, I still want you to think of this as just being, a distance over time to give us that speed or rate. Oopsies, what the heck? Think about that example that we had about that Johannesburg to Jerusalem example. We had the distance, which in that scenario, because think we had the sphere of the Earth, we had that distance arc length, and then we knew we could figure out over time, right? And that would have given us the speed. All right, so we're going to talk about three different kinds of speeds. We have linear speed, which is, what we're really familiar with, that distance over time. We have angular speed, which is, a rotation or how fast an angle is changing, angular. And then we have something called rotational speed, which is honestly just an in-between of the two. So let's start with linear speed. Like I said, linear speed is really just distance over time. And specifically in terms of what we're talking about, this unit, this really is arc length over time. Which again, why this is relevant to what we're doing in this unit is because a lot of times we're talking about arcs or circles. So arc length over time. For angular speed, like I said before, we're thinking about rotation or how fast an angle is changing. So this is going to be equal to our central angle over time, or theta, which is always in radians, over time. Maybe you should make a note that theta is always in radians here. And again, we're talking about how quickly an angle is changing as it rotates an object. And last but not least, rotational speed. So we're talking in terms of revolutions. So it's revolutions over time. Rotational speed and angular speed are very similar. The main thing is when we're talking about rotational speed, we're talking about whole revolutions over time. And when a complete revolution, that is. When we're talking about angular speed, it could be any fraction or whole amounts of revolutions. So when we're talking about rotational speed, it's actually unitless in our numerator. It's however many revolutions over time. So, however many revolutions over hours or minutes and so on. So for example, in our cars, we have a speedometer, which tells us the speed that we're going. We also have a tachometer, which tells us the amount of revolutions per time of our engine. So maybe you've seen, something like this. Not all cars have them, but, it's telling us our revolutions per minute times 1,000. So just an example of where we might see something like that. So rotational speed really is the intermediary between linear speed and angular speed. We know that 2 pi is equal to 1 revolution. And we know that 1 revolution is equal to circumference. Right? So we know circumference is the linear distance of 1 revolution. So the conversion between linear speed and rotational speed deals with circumference. All right, so let's put this into practice. It says here, a car is moving at a rate of 40 miles per hour. The diameter of its wheel is 2.4 feet. So what we want to do is we want to find the rotational speed of the wheel in revolutions per minute. Okay, so note here, this right now is given to us in linear speed, miles per hour. We're trying to convert this to rotational speed. So we want to go all the way from miles per hour, do all kinds of conversions to make this into revolutions per minute. Okay. One thing that you're going to need to know is that, how many feet are in a mile. In case you didn't know, there's 5,280 feet in 1 mile. All right, go ahead, put me on pause and try this one on your own. All right, so let's check what we did here. Anytime that we have one of these problems, we always want to begin with what we were given, which in this case was 40 miles per hour. Okay, so we knew that we were trying to convert from revolutions to minute. Okay, so, you could have done this in any order, of course. Like maybe you started by converting hours to minutes, which to do that, of course, we're going to convert hours. We know that in 1 hour there's 60 minutes. Okay, so maybe you did that first, and that's totally fine. The part that is probably the trickiest here is knowing, okay, well, why did I have to convert miles to feet? The reason is because look at what they told me about the diameter of the wheels. It was in feet. So I started by that, and I told you how many feet were in a mile. So I converted my miles to feet. And now you're probably like, okay, well, what's going on here? Well, remember on the previous page, I was saying how in 1 revolution, it's equal to the circumference. 1 revolution equal to circumference, which this is the circumference, right? Remember, circumference is 2 pi r, or diameter times pi, and it told us that the diameter is 2.4. So, I should cancel everything else out here. So finally, I could get rid of feet units, and I have revolutions per minute remaining. Multiply it all out, I got 466.854 revolutions per minute. Okay, so now we're going to have to use that answer here to find the angular speed of the wheels in radians per minute. Okay, so we're going from revolutions per minute to radians per minute. So let's see if you guys can do this one. Okay, so like I said, we were starting from revolutions per minute. We're trying to finish with radians per minute. That's here. So the key thing here was remembering that, we know that 2 pi radians is equal to 1 revolution. Now I'm left with radians per minute. Where did this come from? Remember what we talked about on the previous page. 2 pi radians is 1 revolution. These are going to be really helpful for you in terms of these conversions here. Okay. All right. Another example. It says a lawn roller, 30 inches in diameter, makes 1 revolution every 5-6 seconds. We want to find the angular speed in radians per second. Well, if the last ones you needed a lot more help in terms of figuring out how to find the answer, maybe now this time, second time around, you can do this more on your own. So remember what it's given to you right now is in revolutions per second, and you're trying to convert to radians per second. The only thing you have to convert from is revolutions to radians. So let's see if you guys can do this one. Go ahead and put me on pause. Okay, maybe this one went better for you. So all we got to do is convert from revolutions to radians. And remember, we said just before that 2 pi radians is 1 revolution. So you should get 7.540 radians per second. Last one here. How fast is the roller moving across the lawn in inches per second? Go ahead and pause me here. All right, once again, check out here that it's asking for our answer in linear speed. So the key thing here, we have 1 revolution per 5-6 seconds that was given. We wanted to convert this revolution to inches, right, which is in terms of circumference, right? And think about what we were given. It said that the lawn roller was 30 inches in diameter, which makes this our circumference. Again, we keep using these two important, what do you want to call it? Properties? It's not a property. Rules? Word. Those words. Okay? Something weird happened. But you guys got my final answer. If you are confused, make sure to ask your questions in class.